Okay. Oh, no, go away. And it always helps if I get the projector turned on in here. So week 6, right? No, week 5. Week 5, right? Yes. Yeah. So we're coming towards the end. Okay. All right, chapter 6. Like I said, we're going to go over files, and we're not going to go over exceptions. If you feel inclined, feel free to read the exceptions section of the chapter. It's worthwhile, and any other language that you simply get into and get involved with is going to have exceptions, and you're going to talk about exceptions. And so it doesn't hurt to know a little bit about exceptions already, but we do not actually cover it. If you have questions, though, you're more than welcome to send me an email, and I'll answer anything I can, even though we don't cover it. So tonight we're going to talk about file input and output, using loops to process files, processing records, and not exceptions. All right, so when it comes to your program, as you start to mature in your programming language, you take in input, right? We already talked about how an application means very little if it does the same thing over and over and over again. If you don't have some way to vary input and output, if you don't process data, if you're not doing something with it, then it's an app that does nothing important. Or at least it'll do it once, right? Like if we write an application that adds 5 plus 3, it's important once, and then it's not important anymore unless you need that again somewhere, right? So, but to create a variation where I can add different numbers, that gives it value. Well, we're getting to that point where we're moving on to the next common place where we get data. So we've asked user input. Now we can start, we're going to talk about tonight, we're going to talk about getting data from a file. And then typically the next place you would start getting data from is from a database, right? So those are the 3 big places. And the other thing about that is now we've got data, what do we do with this data? Again, we learned a long time, to be honest with you, in the 60s, retain all data. Retain all data. We never throw away data, because the only thing worse than bad data is no data. So kind of keep that in mind. So we're always asking for user input, which is reading in data. And then we output to the screen, which is doing something with that data. We're writing that data somewhere, right? Well, now with the file, we can read data from a file and we can output data to a file. And at some point, you'll talk about databases. We can read data in from a database and write data out to a database. Now, there are other means of input and output, and it changes over time. At one point in computers, data input and output was done via cards that were punched, holes in a card. And so again, and now that seems ludicrous, right, to us. But at one point, that was how data was entered. In fact, I started programming long enough that that piece of technology was pretty much already on the outs, but education was still teaching that. And so I actually, one of the first classes I ever took legitimately in programming, we actually did have an entire class on data cards. I'm gonna tell you, by the way, here's something to know about data cards. You wanna number those guys. You take a pen and you number them 1 to whatever number, because when you were walking somewhere with them and you drop them, you now are screwed because you do not know what that what those cards order was, and for whatever reason, again, they weren't like put through a printer or anything. I mean, it was a special kind of machine that punched them, but nothing was ever numbered. So you would see someone with these stack of cards, and they were taking a black marker, and they literally just 1, 2, right on top of the big thing, because it doesn't matter, 3, 4, and so it's one of those things you don't learn until you drop your deck of cards, and you're shaking your head. Yes.
I was talking to my mom about computers. She said that she learned how to work on those when she was in high school.
Yeah, I mean, one thing I'll tell you is, while a lot of the front end stuff has changed over time, a lot of the core technology is still very similar. We still go back to bits, zeros and ones, right? We still go back to memory management. Like Python, one of the nice things about Python, you don't have to worry about memory. It handles it all for you. But there's downsides to that. You have to go with whatever Python goes with. You get into a language like C++, where you can actually do the memory manipulation. You can speed things up based on the knowledge of what memory types you're going to use. I'll give another example of that is I wrote a program a long time ago, probably about 15 years ago, that was for geocoding. And essentially what it was is someone could come in and put in their zip code and then say, pull a 10-mile radius of all the people that met this criteria. And to do that, what we did was we divided up the country into about a 10th mile big set of squares. And we wrote those squares across the United States. And then we numbered them. And so what we could do is we could pinpoint what square you lived in or what square you wanted. And then from there, using math, we could figure out all the squares that basically was within that circle of how much ever radius it was, right? It looked like an 8-bit circle because it's squares inside of a circle. But we could then go through and we even figured out the technology. We said, well, if the square is more than 75% within the circle, count it as in. And then we would go through and we would look at each square and figure out if the person that lived in that square matched the data. And then we would mark that as true or false. Well, that was great, but imagine how many squares cover the United States. It was taking forever when we allowed it to use what's known as linked memory, which is memory is all over the place on your hard drive, in your RAM. It's all over the place. And each piece of memory points to the next piece of memory, wherever it needs to be, and to the previous point. Now, the good news about that is no matter how big the memory piece gets, you can accommodate it because memory can be pushed all over the place. However, it's really, really slow because each time you look at a square, you then have to look at the address for the next square in memory, go there, read that data, and then look for the next square. And what we found was we just loaded these machines up with a ton of memory and we wrote them as consistent array blocks. And so instead of having the hard drive spinning in each revolution, it can only pick up one piece of information. Literally in one revolution, it could pick up the entire array. And so because of that, we went from something that would take I don't know, the thing was taking like 20 minutes at first to literally it took about 3 seconds when we changed that memory mapping. In Python, you can't do that. So that's why it's good if you're really wanting to be a good programmer to start to get to know some of those older technologies. I'll never be upset that I ever learned assembler because I know now what's going on behind the scenes. And so when I'm writing something in these higher level languages, I know the small little tricks like, okay, this, I'll give you another example. In C#, a structure is written on, excuse me, on C++. A structure is written on the stack, and a object, a mem object, is written in the heap, which is 2 types of memory. Well, the problem with that is, again, stack memory is really, really fast versus heap memory, but stack memory is really small. And so I didn't realize what was going on with the different pieces of memory until I learned assembler. So again, never shy away from learning some new stuff, especially some of the older stuff, because a lot of that older stuff is still way down in the bowels of the computer, and it's still a lot of the technology that's still being used. We've just added layers on top of it. Sorry, I went off on a rant. All right, so those are the 3 big ways we get data. User, we've got files, and then we have databases, right? There are others. We just talked about one. Another one that we've talked about already in this class is radio frequencies. So there are these devices you can get for your computer that will listen to radio frequencies in the air. And the reason why they do this is they use the white noise around you to help generate random numbers for you. So you go from pseudo random numbers to truly random numbers. So there's another form of input. What other type of inputs do we have? In outputs. I mean, sure, at the end of the day, it's probably a hard drive somewhere or some SSD somewhere. But now we can read and write data from the internet, right? Amazon's got the S3s. Now to us, we don't know what the technology is behind that. All we know is that it's an input and output source. We can connect to it just as if it were a hard drive. So other forms of input. One day, you know, actually we're already doing it. We'll actually read brainwaves as well and interpret them. Other forms of input are cameras, projectors, output. So it's all over the place. But the 3 big ones are user input, files, and database. So when it comes to database, to file input and output, we're writing data. We talk about we're saving data. And that means we have an output file. Output files, by the way, is one of the more risky things when it comes to programming, right? Because you can overwrite files, you can corrupt data. So we always want to be careful when it comes to outputting files. We want to be super careful, and we'll talk about this in a moment, whether we're outputting or reading a file, we want to make sure we're opening it in the correct mode. Sometimes, some languages allow you to open a file and both read and write. And you don't want to do that if you really are only reading data. Why take the chance? Why allow yourself or your application to accidentally write data to a file if you knew the process was only going to ever read a file anyways? So in that case, open it as a read-only file. So when it comes to, and by the way, we do have all varying levels of knowledge in this class. So this may feel very elementary to some of you and not to everyone. So just bear with it. If it is something that you're pretty familiar with already, we'll buzz through it pretty quickly. So when it comes to file output, we write data to a file. It's stored on a hard drive that in this case is shown as a cylinder, right? Or a platter, which is funny because we're getting to the point where most hard drives aren't platters anymore. They're nothing more than stack of static memory, They are, for all intents and purposes, memory modules, right? They're not platters anymore. There's no magnetic fields going on. SSDs, by the way. But they still somewhat act the same way. They tend to store data in these chunks, as we see here. When we take data and we store them to a file, it takes it from RAM and puts it onto the hard drive. And just the opposite when we're reading file. Data comes off the hard drive and goes into RAM. So reading data from is that process for retrieving data from a file. You're reading data from a file. To do that, you have to have an input file, which is where the data is coming from. So essentially, when you go to do this, you're going to do 3 steps. You're going to open the file, you're going to process the file, and then you're going to close the file. Closing the file, by the way, is just as important as opening the file. The reason why I say that is some languages, Python's one of the better ones, will help in mitigate any problems you might create by not closing a file. But you can run into problems where if you don't close the file and Python doesn't release all the resources right away, if someone goes to try to open that file, it'll give them an error. All these kind of things can happen. If another program tries to read it, they'll get an error. So make sure you're closing the file. So we just talked about this where data is on the hard drive and we want to read it, it lifts it up into RAM. And for us, the lifting of data into the RAM is when we take data from the hard drive and we store it inside of a variable. That's when it becomes RAM. When it comes to file, you essentially have 2 types of files. You have a text file and you have a binary file. Text file, literally, you can open it up and see the text. Now, just so you know, a text file doesn't always mean it's readable because the application that's storing that text file may do things to that data to make it incomprehensible, but it knows how to read it. But for the most part, data that's stored in a text file is easily read by opening the text file in any program, any text editor, and you can see it. Whereas a binary file is truly a file that's represented by bits. So when you open it in a text editor, it'll look like a bunch of weird characters. And that's because the text editor is trying to take the bits and kind of rehydrate them into ASCII characters or even the ASCII extended characters and trying to make some semblance of what that data is. It doesn't really know that it's just a straight up binary file. If you ever try to open something like an Excel file, this. Any file. Where's my, okay, here we go. So this is a binary file. And we open it up, and as you can see, it looks like it's kind of text, but it's not. It's this text editor is just trying to read that data and make a semblance of what it should be. But it's just gobbledygook to us. Okay. So text files are great for writing some somewhat simple files. They're pretty fast. They're pretty easy to use. We like text files when we can. Okay, even if we're encrypting the data to make the text file a little less easy to read by the general user, Sometimes we do that because we want to use something easy and peasy like a text file, but we don't want a user to try to circumvent maybe our application and go into that file and make changes to that file. So to stop that, we might just encode the data or change it up a little bit, or usually, like I said, use some kind of encryption to rewrite it, but we'll still use it as a text file to keep things simple. Whereas a binary file is great for data objects. It's great for this idea. Like, one of the things we're going to do today is we're going to write data from input that we take to a file as a record. Well, that's great. We can also take that record and we could make an object out of it. And instead of saving it straight as data, we could save it as a memory block to a binary file. It makes that file a little bit faster, oftentimes a little bit more smaller than a text file. There's a lot of upsides to that binary file, but again, there's a lot more involved when it comes to creating binary files than that. So we have two ways to access data when it comes to data stored in a file. And that's sequential access. That is, we read the file from top to bottom, left to right, from beginning to end, and we don't skip ahead. Usually when it's sequential, it means we can't go backwards either. And oftentimes that's actually can be, at least I find, can be more problematic sometimes, is we can't go backwards. Once you've read it, it's gone. You're on to the next line. To go backwards, you have to literally reopen the file and start again. Go to wherever you were, -1 if you want to go back one row. For direct access, you're opening the file, you can jump directly to any piece of data in the file. Again, these both have ups and downs. The upside to sequential access is it's a lot faster. And it's because it's not loading a whole lot of the file into memory. It's only loading typically what it needs at that moment into memory. For direct access, oftentimes needs to load the entire file into memory. That's what allows it to jump back and forth, and you can skip around. So it's slower, but sometimes more useful. So again, depending on what you're trying to do with your data, you may want to use the different file types or file access stored types. Example of this was we were writing an application that went through and substituted, I think I used this example once in this class before, substituted the plus signs out of a file because the data coming to us had these plus signs and minus signs for positive and negative integers. These files were gigabytes big. So there's no way you can use traditional file load, which oftentimes is a direct access file load. We purposely wrote it to use sequential access, so only so much was ever in memory. It would pull up the next line in memory, do what it needed to do that line, and then dump it back to the file and then erase it from memory and go on to the next line. Because of that, it was a lot faster, but we knew we could do that because we weren't looking to go backwards ever. We knew we were going to do each line one at a time and then never worry about it again. File name extensions. Everyone that has worked on a PC typically knows what a file name extension is. It's PC's way of knowing what the file type is. So TXT is a text file. XLXS is an Excel file. PNG is an image file. Mac does something slightly different, but oftentimes Mac now is using the 3-letter initials as well, because again, they're trying to make sure that they are in sync, especially when it comes to image files, where a PC can easily open it versus a Mac. So oftentimes you still see that file extension. File object. So an object associated with a specific file, this comes to the actual programming. When we go to associate in our program, we need a handle that allows us to act on a file, whether we're reading it or writing it. So it's kind of that gateway It's a variable that's a gateway to our file access. It's known as a file object. So in this picture, all it's really showing you is, okay, so we have this variable name, and whatever our variable name is, including we wanted to call it variable underscore name, is pointing to this file object that then is pointing to the actual hard drive or wherever we're pulling the file from. The file object has a lot of stuff in it that we probably won't even use. It's doing a lot of things for us. It's actually creating the data streams and all the things that are needed behind the scenes to make reading and writing a file for us very simple. So there's a lot of stuff in that file object. And because there's a lot of stuff in that file object, we can do some of these things. We can call the open function. So that obviously is used to open a file. And when we do that, we get to specify the file name along with the mode. Remember I was telling you, if you're reading from a file, you want to open it in read only. There you go, read only. Or writing and appending. Now, what do you think is the difference between writing and appending? Sorry? Correct. So when you do W, if it notices that the file already exists, it will overwrite it. A says, hey, if there's a file there, we're going to append to it. Not overwrite it. So we need to specify the location of a file. If open function receives a file name that does not contain a path, it assumes that the file is in the same directory as the program. This is really key to know. For the most part, keep things simple. Read and write the files to the directory where your program sits. Okay. So for me, I created a folder on the desktop called week 5. And so all my data files are going to be read and written to this directory because I'm not going to specify a path. But if you wanted to, you can. If program is running and the file is created, it is created in the same directory as the program. You can specify alternate paths and file names in the open function. We just talked about that with this file object in that file name. We would give it the full path. Now we're going to talk a little bit about writing data to a file. So we talked about opening, which this is how we open a file, read, write, and append. Now we're going to write data to that file. We've opened it with the W mode, and we're going to use the file object variable name dot write, and then a string. When you're done writing to a file, make sure you call the close. This frees up resources that are keeping that file open. It allows the system to know that that file is now closed and other things can be done to it, including being deleted. Sometimes having it open will block other applications from reading it. In somewhat a similar fashion, we can read data from a file. So we're going to use read, which reads the entire file contents into memory, all one big chunk. If you try to do this, by the way, on a 1 gig file, you're going to get an error because there's not enough memory. Read line, which is something you're going to use much more often, is going to read per line into your variable. It will go all the way up until it sees this very specific inline character, which is this N stands for new line. And to get new line, you have to have this slash and then the N. The read position marks the location of the next item to be read from a file. So again, it's basically, if you're using read line, it's going to point to the very next line. So with that being said, the read line method is the one we use most often. And because of that, that new line character is something that we'll either have to append to our data when we're writing, or oftentimes we'll have to exclude it when we're reading. When we add the new line, we want to concatenate it. We can do that with the plus sign. We can also do that with formatted strings, the F string. Those are the two most common ways to do it. And then when we're reading data in, we got to remove that. So we're going to use a new function called rstrip, which, by the way, stands for right strip. So it's going to strip from the right, not from the left method. And this string method that strips specific characters from the end of the string. So now let's talk a little bit about appending that data. So we know when we open a file with W mode, if the file already exists, it's overridden. We've already talked about that. To append, we want to use the A mode. If the file exists, it is not erased. It does not exist. It is created. So oftentimes people will just use the A mode because that way, if it's there already, then you'll just open it and read and write to it. If it's not there, you'll create a new one. Again, that's great, but be careful because when you start using sometimes these catch-all kind of ideas, then you made your code a little less strong because now you're letting your code be a little bit too autonomous. Not that it's always wrong, but if you know that your data always needs to write, as in overwrite a file, then don't use the A mode. When it comes to reading and writing numeric data, if we're writing to a text file, then it needs to be a string. So to do that, we're going to start using this str function. Just like we used int around inputs, we can use the str function to kind of do the opposite. We can take integer data, wrap it with this str, and it turns it into a string. It literally puts quotes around it. When numbers are read from a text file, they're read as a string. So then you're going to have to use that int and float functions to convert strings back to numeric value. By the way, this is one of the reasons why the chapter normally goes on and now talk about exceptions, is because this is where you start to run into errors. When you read data in from a file that you think should be an int and you go to just convert it to an int, an error is going to be thrown because it wasn't an int. We're not going to talk about that, but that's kind of why they start going towards the exception. So files hold as little data as they want and as much data as they want, right? Just to some degree. So when we're calling the read line, we need to know when we come to the end of the file. It's pretty simple. When the results come back as an empty line, then it means you're at the end of the file. Well, what about a blank line? What if the system reads in a blank line? How will we know the difference between that and the file? Anybody? Anyone want to give it a shot? Okay. The difference is when we hit the end of a file, it truly will be an empty string. It'll be just like this with nothing in it. When it's just a blank line in the file, you'll still have the new line character in there as well. So it won't technically be blank. There won't be any true string data, but the new line character will be there. So you'll still be able to compare the difference between line is not equal to blank versus line is not equal to inline character. We said three things: open, process, and close a file. This is that process portion of the file. So this is a nice little logic loop to show how that kind of works. Let's blue it up a little bit. So we open the file. We use that read line to read the first line from the file. By the way, this is known as priming the loop, because we haven't gone into the loop, but we need that first piece of data to compare against our loop to make sure we should even go into the loop. So we got to prime the data. Once we prime the data, then we compare it, and hopefully there is data for us to continue on with, in which case we actually go into the loop. Did the read line return any empty string? No, then we're going to process the item that was just read from the file, use read line to read the next line from the file, and come back and again, did it return that empty string? Yes, well then we know we're at the end of the file, we can go ahead and close the file. If not, we're going to process the line that was just read, read the next line, keep doing this circle until we finally get all the way to where we get that empty string and we know we're at the end of the file. So we then close the file. Everyone doing all right so far? Make pretty good sense? All right. So how do we use file coming in from the read lines in a loop? One way is through the for loop. Remember, the for loop is designed to take anything that is an iteration. So whether it be an array of numbers or an array of text lines in a file, if it can be turned into an iteration, then it can be used in the for loop. Lucky for us, the file object itself will automatically convert and tell the for loop that this is an iteration, and it will give line by line back to the target variable, which is in this case the word line in this. So every line is going to be line by line is going to be put into this line variable that we can then use in our statements. Always remember the loop iterates once over each line. It cannot go backwards, it cannot go forward. If you go forward, it makes it to where you can no longer go backwards. So you can only go forward. To clarify that, just so you know, that the terminology is, if you want to kind of look ahead of in a file, so let's say maybe you want to, on the line of data that you're working on, you might do something different. If the next line is truly the end of the file, you would do something different with this piece of data. To check ahead, it's normally known as what's called peeking. Peeking looks at the data but doesn't forward your data pointer onto the next line. With what we're talking about here in the file object, you don't have that ability per se, not at least the way we're talking about it. And so you can only go forward, but once you've gone forward, you're there. You can't go backwards. Now we're going to talk a little bit about what it takes to process a record. Because again, now we're starting to get where we're putting this data pieces together. And most of the time when we talk about data, we're talking about records. So we know a record is a set of fields, and a field is a single piece of data within a record. Your first name is going to be a field. Your middle initial is going to be a field. Your last name is going to be a field. Your address is a field, but all those fields put together is your personal record. So we write records to sequential access files by writing the fields one after the other. When we read records from sequential access files, we read each field until the record is complete. So when working with records, it's also important to be able to add records, display records, search for a record, modify records, and delete records. And when they say this, they mean somewhat as a holistic approach. We should be able to do these things. Now, that doesn't mean every time you write an application, it should do these things. I have written plenty of applications that take in data from a file. It reads the data in, writes it into a database, and then never does anything else with it. So it's not modifying the records. It's not displaying the records. It literally is importing the data from a file, text file, into a database. And we're not going to delete records. So while, yes, sometimes we want to do those things, it's not always important to do it every single time. With that being said, that's where we start talking about, are we talking about sequential data files, or are we talking about the random access files? Are we pulling the data all into memory, changing things up, and then writing it all back to the file? How are we handling things? Depends on what we want to do when it comes to processing the record. And that is it for the lecture. Like I said, at this point, they go on to exceptions. I do encourage you to kind of at least read through it just so you have an understanding, but it's not part of the materials. All right. The interesting thing about file input and output, it probably doesn't make a whole ton of sense. It does in a logic sense, but you don't really get a sense of it until you actually start doing it. So we're going to do a little bit of the homework. So here is program 6.1. I have done a little bit of the outline, and then we'll jump in and actually do this set of code. So what was the homework? Let's go. It says, write a program that creates a text file to store the inventory of a retail store. Acquire the item name, quantity in stock, and unit price of each item in the inventory from the user keyboard input. Use a while loop, and now they're being very specific here. Use a while loop because the size of the inventory is unknown. Each datum should be on its own line in the file. And by the way, that's another very specific piece of information. Each datum, which in this case they're saying each field should be on its own line in the text file. The reason why they're saying that is there are several ways to store data, records in a text file. One way is known as fixed length. And that is where all the fields of a record are stored on one line each. But each field is a certain number of characters. So let's say we're doing the example we talked about before, which is a person's name, and we'll just go with their zip code, okay? So the first thing I would say is, how long do I want each field to be? Well, let's say for the first name, we make it 20 characters wide. So what happens is it goes 1, 2, 3, 4, 5, 6, 7. Let's see if I can. By the way, we can see down here what column we're at. And we said it's 20 characters wide, right? So this is the start. Now we do the last name. Let's say we say the last name is 30 characters wide. And then the zip code, we always make that 5 characters wide because we're just going to go with the basic. Well, the next record would look like this. and so forth and so on. Because our file, when it goes to read in, would read the line in like this and say, hey, the first 20 characters is the first name, pull that out and strip off all the spaces now. And the last name is starting at the 21st character is 30 characters long, pull that out, strip off all the spaces. And then finally, the zip code is sitting at the 50th character and it's 5 characters long. That's what a fixed length is. Where it becomes problematic is, what if one of these fields you didn't account for enough characters? What if all of a sudden we have a first name that is bigger, or more likely a last name that is bigger than 30 characters? We would have truncated data. Fixed length, very fast when it comes to reading data in, very fast writing data out, because there's no complicated other than read and write a certain number of characters. But again, the downside is two parts. One is what's known as file bloat. Your file gets really big because it's got a lot of spaces in it. And two, you can have truncated data if you accidentally make one of your fields too small. So how do we solve that? Well, one way is known as using a delimiter. One of the most common delimiters is the comma. Now, technically, your fields can be as long as they need to be. And there's no bloat in your file because literally when you're done type the data for that field, you put a comma and you move on to the next field. So it's only as big as it needs to be, technically, field plus 1 character, which is the comma. But right away, what's the problem with this mechanism? What if a comma is a part of your actual data? What if we're in a new day and age and someone's born and they actually put the comma in their first name? The system would choke on this because it would try to pick up these first 3 fields. And then this would choke because this would be expected to be an integer field, and it's not. Okay, well, how do we solve that? Well, one way they solved it was, then we're going to put what's known as qualifiers around every field as well. And now the system says, oh, well, that comma is inside of a quote, which means that it's part of this entire field, including the comma itself. That works great. It's one of the way Excel does it when it writes out to like a CSV file. That's great. Another way to do it is to use a less common delimiter. A lot of times we use pipe. This pipe isn't oftentimes found in the common use of characters. That works. But however, like anything else, we came across data that all of a sudden had pipes in it. Screwed up the system. So then we started using what's known as non-readable characters. So in this case, we're replacing all the pipes with tabs. Behind the scenes, the file, if you were to look at it with invisible characters turned on, you would see this everywhere the tab is. That's how your computer would read the file. And we would convert the tab into a new field. And this is all great, but there's some complexity here because now we're concatenating data, we're putting all these things together. So finally, there is one last way you can do it as well. Where each data is just on its own line with a blank line in between. Now remember, when your system reads it, this is how the data is going to come back to you. And technically, that last line is going to come back as a blank line with no new line character. Everyone with me? So, let's go ahead and fill in some blanks here. So we're going to set up variables. Now, this is something that is somewhat of a preference. A lot of organizations like it when you set up variables that you're going to use in your program at the top. It just makes it sometimes more readable. So we're going to do that instead of initiating the variable when we need it. We're going to go ahead and initiate them at the very top, so they're just there. To make things nice, we're always going to again, a big good habit that I have is whenever I create a new variable, I go ahead and assign data to it right away, even if it's blank data. That way I don't worry about, especially in other languages, you could have then bad data sitting in a variable that you didn't even know. So this is just a good way to make sure you don't have that going on. We're going to need a flag for our for loop. Our while loop, we're going to need a flag. So this is my sentinel, the flag, to let the for loop know to keep going. We're not going to go ahead and say, hey, you know what? We need that for loop, that while loop, right? Because that was, sorry, one moment, please. Oh, it is using a while loop. So I'm sorry, we got to change our strategy just a hair. Go back to, we need to, no, we can do that. Right? And, oh, we need to go ahead and create a file. So let's go ahead and call this, I feel like I spelled that wrong. Inventory file object. Now we've talked about this before, but we're going to go ahead and utilize it. We're going to actually completely specify the parameter that we want to talk about. And we're going to do the mode of W. Now we need to get the user to input some stuff, right? So the first thing asked us was, now remember the input coming to us from the console is already going to be in string format. Even though they're going to give us a number, console is going to read it as a string format. So we don't have to do the str. It's already been done for, it's already coming in as a string. Okay, now that we have all three pieces of data, let's go ahead and write them to the file. So we have inventory FO. And we are going to write an F string and then our new line character. Whoop. Sorry. Now we got to write that blank line that we talked about. Oop, did it in the wrong spot. Okay, so I'm sorry. And again, I'm writing this as we go along. So one of the things they say here is enter item name or enter to quit. So because of that, we need to go ahead and say if item name equals nothing, that means they don't want to continue on, right? Oh, thank you. And it's that simple. So it's going to keep going. If the item name comes back as being blank, they've hit enter, and we're not going to go any further with this. So we're going to go ahead and say keep going equals false, and we're going to let it drop out of the if block, which will come back to the while block. It will stop here. Otherwise, take in the extra 2 pieces of information, write all 3 pieces of information, and then write your final piece of information to get them to go ahead and that blank line. Sorry, lost my track of thought. All right, now we can go ahead and close that file. Well, let's give it a shot. All right. Now, if all worked out, you have this inventory file. We open it with a Notepad++. There's hats 12, 1999, and then you can see there is a blank line here. That CRLF is the /n. /n stands for carriage return line in text file. Okay. So we're gonna leave that inventory file there. Go ahead. Let's run this again. And this time we're going to do shoes, 6, 49, 95, shorts, 18, 24, 95. There we go. And then tops, 10, 17.99. Now, it should have overwritten the original inventory file that we had there. There's shoes, 6, 4. So it's doing a good job. Any questions about that homework? Pretty much gave you the solution on that one. Make sure again that you're playing with it and you know what you're doing with that. Change it up a little bit. When it comes to reading the file, We do things a little bit different, but very similar to what we did before. The difference here is we're going to have and please understand now, I'm not giving you the entire solution. I'm trying to provide some help and clues on how to do this. So we're gonna create a file object by doing the open. And we're doing it by reading it. Oh, that's fine. Whew. And then the first thing we need to do is prime the loop by pulling in that first data line. With that, this is where we will set up our while loop that looks for that empty string. Because if it's an empty string, then we know that there's no data there. We're at the end of the file. If there is data, then we go ahead and read the next two lines of data in because we know that this particular record is 3 fields big. Then we strip by the way, if it doesn't automatically do the indenting for you like that, it usually means that you're missing a column. So now we're going to strip that new line character. So now name is name without the new line character. Go ahead and make sure that at the end of the loop, you try to read the next record in, because if there's nothing there, if there's no new record, the read line is going to return that empty string again. And when we come up here, the while loop is going to go, empty string, out of data, and it's going to come out of the while loop. Never forget to close your file object. Oh, and then I apologize. Up here, where we say to display record, now that we've stripped everything out, we can simply just do a print. Right? So that's the basics of reading in the file and displaying it out to a user. Any questions? So that is tonight's class. That is the lecture. I told you tonight would be a little bit of a shorter one. What I'm going to do is I'm going to hang out here for a little bit. If you want to go ahead and do your homework, you're more than welcome. If you want to go ahead and depart, you can. If you have any questions, you can always shoot me an email. And again, to remind everyone, next week we will not have a in-class class. I will post the lecture online as a recorded video. All right. Thanks, everyone.
Thank you, Mr. Waits. Have a good night.
You too. Thank you.